going to be solving the chemistry paper 6 alternative to practical February-March 2025. So let's get started. The first question, inks contain different colored substances called dyes. A student used chromatography to investigate the colored dyes contained in 6 different inks. The student drew a baseline on a sheet of chromatography paper. The student then placed a spot of each ink on the chromatography paper and set up the apparatus as shown in figure 1.1. The student made two errors. Part A, identify the 2 errors the student made. So first things first, you can see that the inks are placed below the baseline, but they should be placed on the baseline. So that's the first incorrect thing he did. Second is the water level is not touching the chromatography paper. So if you look closely, you can see that the paper is not touching the water. So that's the second error he made. So that's the 2 errors the student made. Next question, part B. State the name of the equipment used to draw a baseline on chromatography paper. So we all know we use pencil because pen, it will dissolve in the water. So we have to use a pencil to draw the baseline. C, first question, identify an ink which could contain only one colored dye. So as you can see, it can be yellow or blue because you can see that you can see that they only have one color dye, blue and yellow, so that you can write either of them. Next question, part 2, deduce which ink could be mixed with the blue ink to make the black ink. So it can be orange ink because you can see if you mix the blue ink and the orange ink, you can see you're getting a black ink. Part 3, deduce the color of one dye that is contained in all 3 of the orange, green and black inks. So you can see it's yellow because orange, green and the black ink are like in the same alignment, so that's why the yellow ink is the answer. Question 2, a student investigates the temperature change when aqueous copper sulfate reacts separately with 2 different metals, zinc and iron. The student does 2 experiments. Experiment 1, use a 50 cm cube measuring cylinder to pour 30 cm cube of aqueous copper sulfate into a 100 cm cube beaker. Use a thermometer to measure the temperature of the contents of the beaker. This is the temperature at time is equal to 0 seconds. The next point, add 3 grams of zinc powder to the beaker. At the same time, start a stopwatch. Using the thermometer, continually stir the mixture in the beaker. Measure the temperature of the mixture every 30 seconds for 210 seconds. Empty and rinse the beaker with distilled water. And experiment 2, repeat experiment 1 using 3 grams of iron powder instead of 3 grams of zinc powder. Now here's a table you need to fill out. So part A, complete the table 2.1 using the thermometer diagrams and calculating the temperature changes from temperatures at 0 degrees. I have done the question. So all you need to do is just read the thermometer diagrams and then subtract the initial temperature from the final temperature, which you will see, for example 33.5 degrees. So I subtracted 24 from it and I got 9.5 over there. So that's the temperature change, and you need to do the same for rest of them, and that's it. So let's move on to the next question. Part B, complete a suitable scale on the y-axis and plot your results for experiment 1 and experiment 2 on figure 2.1. The point at coordinate 0, 0 has been plotted for you. Draw 2 curves of best fit. Both curves must start at coordinate 0, 0. Label both the curves. So let's draw. So we need to look at the diagram which the answers we gave for the previous question, and just need to plot the points. So I'm just gonna, it have been labeled for us already. As you can see, temperature change over there since time 0 seconds and the time in seconds. Now we just need to label the scale. So it's on the scale, so let's do that. So for plotting the point, you need to choose the best scale for plotting the points. So we chose the in multiple of 5, so 5 and 10 and 15. So as you can see, because the temperature changes are in 0.5s and it's like in 5 scale, so that's why we chose the best scale for the points in multiple of 5. Okay, so as you can see, we have plotted the graph, and you just need to just cross check the points from the table and just plot them on the graph. So let's move on to the next question, part C. Extrapolate the curve for experiment 1 on your graph in figure 2.1 to reduce the temperature change since time is equal to 0 seconds for in experiment 1 after 240 seconds. Show clearly on figure 2.1 how you worked out your answer. So extrapolate, it means just extend your graph. So let's just extend the graph over here for experiment 1 only. Now we need to just see, all we need to do is just like look at 240 seconds over here as it said in the question. Look at 240 seconds and reduce the temperature change. So let's do that. So seems like it's coming on almost 16, so we're gonna write 16 over there in the as the answer, 16 as the answer. Now for the part D, state which experiment 1 or experiment 2 is more exothermic. Explain your answer. So you can see on the graph that experiment 1 is the most exothermic experiment because it has a higher temperature change, so more energy is released. So let's write that as our answer. Okay, moving on to the next part. Part E, predict the temperature of the solution in experiment 1 after 3 hours. So the temperature after 3 hours will be 24 degrees, the room temperature, because it will come back to room temperature as it will get heated up and the reaction will be stopped. Part F, explain why using a copper container instead of the beaker would not be an improvement in this investigation. Well, copper is a good conductor of heat, so it will not prevent heat loss. Part G, describe 2 changes to the apparatus that will improve the result of this investigation. For each change, explain why it will improve the results. So first things first, we're going to be using a burette instead of measuring cylinder because it is more accurate when measuring volume. And the next change, and the next change will be using a polystyrene cup because it acts as an insulator, so it will prevent heat loss. Question number 3. A student tests 2 substances, solution A and solid B. Test on solution A. Solution A is aqueous chromium 3 chloride. The student divides solution A into 3 approximately equal portions. Complete the expected observations to the first, so part A, to the first portion of solution A. The student adds aqueous sodium hydroxide dropwise until it is in excess. So write green precipitate and solivary in excess. That's the answer. part B, to the second portion of solution A, the student adds about 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. This is observations. The observation will be no change. To the third portion of solution A, the student adds about 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate. The observations will be a white precipitate. You can see the table, which I'm going to be adding to the other side. You can see. So now moving on to the next part, tests on solution solid B. Table 3.1 shows the tests and the students' observations for solid B. So you can see the test over here. Now part D says describe how to carry out the flame test used in test 1. First things first, you're going to be using a platinum wire, a clean one. So to clean it, you need to dip it in concentrated HCl. So and then hold it onto the blue flame, the edge part of the flame, and then observe the color change. That's it. By clear pull the camera. Blue flip. Part E, identify the ion that is tested for in test 4. So it will be NH4 plus ion. As you can see in the table, it is showing NH4 plus. So part F, identify the two ions which are in solid B. So according to the results, as you can see in the table, it will be lithium. So you're gonna have Li plus and sulfate ion, which is SO4 2 minus.